What's up, guys? All right. So, last week we had a bit of a snafu with YouTube going down. Yeah, some random garbage. So we're going to start from scratch today. Basically this lesson is about it's about characters, booleans, literals, and variables. So we're going to kind of run through that stuff. It's a lot of fundamental, foundational stuff. By the way, I like the word stuff. So we're going to get through this stuff pretty quickly. Hope to get it done about an hour, a little over. But I do want to touch on something awesome I'm going to start doing. I've decided to start helping out some of the local artists by hosting mixes that they've done and kind of doing a little plug at the beginning of each lesson. So this week, if you check the details of the event page, and I'll also add these to the YouTube video, you'll see that this mix that's playing in the background is by a jungle/drum and bass DJ and producer who goes by the name of Mazisis. And I've added all of her details so that you can go check her out, go down the rabbit hole, see what else she's done. She's released a lot of awesome music. She's played all around the world. She's based right here in Boston. So, you know, check it out, give her a follow, and enjoy. So without further ado, let's do this. All right. Also, I have the chat open for the video, the live stream, so I can respond in real time if you've got anything you want to ask. You can totally do that. Otherwise, here we go. All right. So let's start with characters. All right. So what is a character? Well, essentially, and we're going to go to our handy little blackboard here, right? So you'll notice that I have class 4, and then I have my blackboard file. So we're going to start off. And I'm going to notate what a character is. So a character is an 8-bit, or rather 8 bits can be used to define the value. But it's also what's called an unsigned 16-bit. And I'll touch on that in a second. But basically, a character, a raw character anyway, can be denoted in 8 bits. And we'll talk about bits later, but it means that 8 ones and zeros and combinations. So you can get up to, I want to say it's, let's see, 2, 4, 8, 16, 32, 64, 128. So 256 variations. Actually, it's more like 127 because the final value, the final place you can't actually use, it's used for the signed notation, which is something we may touch on later. So anyway, 127, 128-ish maybe, different characters. So this is essentially ASCII characters. So let's go ahead and Google that so you can kind of see what's going on here. So you look up ASCII table. There it is, first one. Cool. And I believe it's this first link here. Oh, check it out. Okay, awesome. So I'll drag this over. So it's a big table from 0 to 127. That's 128, inclusive of the 0. And as you can see, you have what's called the decimal value, the hex value, the oct value, and then the actual character value that's associated with it. It gives you a breakdown here of what it actually means for all these special characters. These are all special. But everything starting from roughly value 32 onward are all literals. Save for a couple. I think delete's not a literal. Okay. So let's start going into some actual implementation here. So you can kind of understand how this maps to the ASCII table, because you're going to say, okay, well, what does that mean? So let's talk about it in Java. I'm just going to jump right into the code and show it. So we're going to declare a character, which is called a char. I'm going to call it my char, right? And we're going to say single tick. You could also do double, but I'm going to explain what that means in more verbosity later. So we're going to use single tick x, right? Okay, so we've declared a character with the value of x, capital X, and we've stored it in a variable called mychar, okay? Again, we'll talk about variables in depth later, but you've already seen these, so it shouldn't be a surprise. So now let's print that out. So, let's see. Oh, you are right. This is why I have the live chat on. Okay, you didn't really miss a whole lot, so let me just kind of explain what I've gone through. I put some notes up here for what a character is, an 8-bit character, unsigned of 16-bit. We'll touch on that in a bit. ASCII characters. We've gone to this website over at Google. We've typed in ASCII table, and the first link that popped up is here, right? And you get to see this chart that shows all the values and what they all map to. Cool. And then we started just jumping into Java, and I'll kind of link the concept of what's in the table to code here in a second, but just follow along. I've created a char called mychar, set it equal to a capital X, and I use single quotes instead of double, because singular characters use single quotes, whereas a string would use double quotes. You don't have to do it that way because a string can have one character, but generally speaking, if you use double quotes, the Java compilation language, Java language, when it's compiled, it thinks that it's a whole string and there's a whole lot of overhead that comes along with that. So this actually confines it to just a simple char. Okay, cool. So then we've done system out print line. This is my char, and we're going to compile that. So go over here to our terminal. And then we're going to go into class 4. All right. Cool. So we're going to Java compile the Blackboard. Cool. Oh, that's right. Cool. So there's the value of my char, just an X. Cool. All right. So that is essentially a character. So let's move over to a demo that I want to show that's going to explain how a character is both a letter or like a symbol, a string symbol, so like one individual character in a string, or it can actually be just an integer. Okay, and this is a really important concept to understand, because if you look at the ASCII table over here, if you look at the value x here, oops, sorry. So the value x down here, it says that the decimal value is 88. Okay, that's important because underneath the hood, that value of the character, even if you set it to a capital X, it's equal to 88. And so you can do arithmetic on that variable and change its value just by performing integer operations. Okay, so let's go back over here. And we're going to go over to our character arithmetic demo. Awesome. Okay. All right. So we're going to declare another character again. Char equals my char. We're going to default it to an X like we did before. All right. And so because I like to save time, I'm just going to copy this. And I'm going to paste it, right? I'm going to go over to the terminal. And I'm going to do char to arith. Yeah, there it is. Cool, I've compiled it. Let's go over here. Let's run it. Cool, same result as before. Awesome. Okay, now I'm going to show you that I can actually add 1 to that value. Okay, so we're going to do my char plus equals 1. Remember, you can also do my char plus my char equals my char plus 1. There's a bunch of different ways. So then I'm going to copy that output. I'm going to do it again, right? And then I'm just going to change this to be my char is now that. Okay, so let's compile that again. Let's run it again. Cool. X followed by Y. So what happened, right? So we set the variable myChart to x, right, which is 88. We've added 1 to it, which bumped it to 89, which maps right over here to y, which is what we got in the output of the terminal. Okay, so as you can see, you can actually do integer arithmetic on a character, and there's a lot of reasons why you might want to do that later down the road, but this actually becomes really useful when you're doing very low-level debugging. You probably won't do that in the short run, but it can be very, very useful. All right, so now we're going to do mychar equals 90. We're going to just straight up set it to the value that we want it to be. So if we set it to 90, we look it up in the table, right? We see 90 is z, right? So we should see x, then y, then z. Okay. Let's copy that output line again and do it again. Let's go over to terminal. Let's compile it. Run it. There we go. X, Y, Z. Okay. So you can see how you can store a character. You can see how you can operate on it as if it's an integer, even though it is a character. And you can see how you can assign an integer value to it directly. Cool. All right. Now, that's characters. Pretty easy, huh? Cool. All right, so Booleans. Let's go back over to the blackboard here. All right, so what's a Boolean? So a Boolean, and I don't know the answer to this. I can find it if you guys want me to, but I would say Google it. So how many bits are a Boolean in Java? That might be a good exercise if you're really interested in knowing. But essentially, a Boolean can be either true or false, okay? So you declare a Boolean like this. You say Boolean, my Boolean equals false, you know, or true. And that's not how you spell false. There you go. Cool. So that's pretty much it. It's really stupid simple. So now we're going to go over to this other demo I have called the bool demo. And we're going to kind of do the same thing in here, right? So first we declare a Boolean, and we're going to default it to false, right? And then we're going to system out that, right? And we're going to say, whoop. Cool. So we've just created a Boolean, set it to false. Now we're going to print it. Let's see what happens. So let's clear the screen. Let's Java compile that. Let's do that. And there it is. It's false. And my colon there is a little messed up. Let's change that and add a space. All right, sweet. So now let's set it to the other possible value that it can be. Right? Let's grab that log it out, and we'll say it's now. Right? So now we're changing it to true, and we're going to print the value. False, now true. Pretty simple, right? So remember the whole 1 and 0 thing where I was saying binary, and I'll touch on that in a little bit here. But effectively, binary really meant, you know, electrical wire signal being on or off. This is basically that. So true is 1, meaning the electricity is flowing across the wire, and false is 0, or the electrical current has been shut off. It's just like a light switch, right? You turn on the light, you're basically saying true. You turn it off, you're saying false. Same concept. It's exactly the same concept, right? At its core, a Boolean is the same functionality as a light switch. And I'm not talking about slider switches. Like, that's a whole spectrum. That's a value. That's almost like the decimal or the floats that we went over, right? Where you can have a real number, like 0.57 between 0 and 1. This is just hot or cold, right? On or off. So, yeah, it's that simple. And that's what everything in programming boils down to, is ones and zeros, true and false. All right. All right, let's do a couple more things in here. So I want to show you, let's see, Boolean value can control an if statement. So we haven't really gone over this a whole lot. We have a little bit. But what I'm going to say is if, and in parentheses, I'm going to say my Boolean, right? So what this says is that if my value is true, or my expression, because it could be like something greater than something else, right? As long as whatever in these parentheses equates to a Boolean value of true, then anything within these two curly braces is going to get processed. So we're going to put this line. This has been executed. Okay. Now, this was true. We haven't changed it, so I expect this to be printed to the screen. So let's verify that. Cool. Looks like it worked. Now let's try a different one. Let's set b equal to false. Okay. And let's copy this, right? And I'm going to say I expect this not to be executed. So I don't expect that log statement to even be seen because false is going to fail this. This will never run. I should never see that text, right? Let's see what happens. Whoop. Where's my compilation? I named my variable wrong. Let's clear the screen. Run that again. Cool. Just to clarify, oh no, let me, I'm gonna make that fail again because I want to show you what it did. So it said on line 19 it couldn't find the symbol. This is your standard compilation bug. So if you run into this, this is your hint, right? So it says variable b undefined. I don't know what that is, and it's clear because I never made a Boolean called b. So there we go. Okay, so I didn't see that log statement, right? And that's what I would expect. I'm gonna show you one more. So check this out. If I say my Boolean equals not my Boolean, right? Whoop. Copy this, right? I'm gonna say this is also executed. What am I doing here? I'm taking my Boolean equal to false, and I'm saying not my Boolean. So what's not false? True, right? So it changes this value to true because it's going to say not false is true. So I'm setting this to not false, or I'm setting this to true. This is true. This should be executed. Okay? And there we go. Now, where this can be useful is if, so I had a Boolean and it was like, is initialized, and I say false, okay? First program, so the first time program runs, I'm gonna say if, well, actually, I'm gonna change this to initialized, not is, but now this is where code can really show its, I guess its value in its English or its readability, like human readability. So if I say if not initialized, then I'm gonna say initializing stuff, right? Cool, but then generally, and I wouldn't say this is the best practice, this is certainly something you can do in your code to make sure things don't get initialized twice, but you could always say, okay, so now that I've initialized things, I'm going to say, okay, cool, everything's been initialized, set initialize to true. So, right, so second time program runs, we're going to use the same. We're going to pretend that there's a bunch of stuff that happens before the next time this runs. And so I run that again, but what I actually have here is We're going to copy this. Right, so in fact, if you were doing this for real, you would put this in a function and you would call it instead of duplicating code. But just for argument's sake, what I'm going to show you is the first time the program runs, it's going to say, if I'm not initialized, which I am not initialized, I'm going to say initializing stuff, and then I'm going to flip that to true. This never gets executed, right? Then I'm going to run it again, and it's going to say if not initialized, which fails. It's going to execute this that says system already initialized, not doing it again. So let's compile that. First time, initializing stuff. Next time, system already initialized. So that is one clear case as to where a Boolean can help you control logic flow, because the first time you do something, you want to notate that you've done it, right? You want to know, you want to record it, and then once you check that value in the future, you can say, oh, I already done that. And there's a whole ton of different ways that this can be used all throughout programming. Cool. All right. So there's our Boolean demo. All right. Let's see. 1 second. Give me a second here. I'm opening up something in my other screen. Okay. Awesome. All right, let's go back over to the blackboard here. All right, we're doing good on time. Sweet. All right, so now we're going to talk about literals. All right. So literals are commonly referred to as constants, right? And so an example would be like 100 is a literal, right? 15.4 is a literal. The character 2, defined just like that, is also a literal. You can also have, a string. That's also a literal, right? So variables like my Boolean are not literals because they can change. This is a literal, the x that we define, but the variable itself is not a literal, okay? All right, so aside from those kinds of literals that we can notate in code, there are a bunch of other literals that we're just going to touch on briefly. I don't expect you to really remember these too much, but if you can, it's certainly not a bad thing. So the first additional literal that I want to talk on is hex, and that has values of 0 through f, or 0 through 9, A, B, C, D, E, F. Okay? So I'm going to go ahead and I'm going to notate that out in a chart here. So I'm going to say 0 is 0x0. So the binary value is on the left side, which is your 0, right? And then the right side is your hex value. Now, hex values always proceed with 0x, so that you know you're talking about hexadecimal instead of decimal. Okay, it's important. All right, so 0001, 0x1. Okay, so I'm gonna kind of copy, paste, and change as I go. It might be faster here. Okay, that's 2. So 3, 4, 5. If you're sensing a pattern here, whoop, sorry, I am not doing this right. Let's go back to drawing board. Imagine these don't exist. This is what you get for working all day. So what is the binary value here for 2? So we can only represent zeros and ones. So we flip a 0 to a 1 to make 1. But then what do? Well, simple. It's kind of like when you get to 9, you go back to 0 in the ones place, and then you change the tens place to the next number up, right? So we're going to do that. Check that out, right? So from here, you would go to 0, 1, 0, 0, okay? I'm just going to do this. It's probably clearer on your end. Okay, so we're slowly just kind of flipping bits back and forth as we go up. And again, not super important for you to remember right now. You can definitely get through the majority of programming without having a whole lot of advanced knowledge on this, but it is really helpful if you want to have a lot more power as a developer. So I would highly, oh geez, what just happened here? There we go. I would highly recommend making sure that you, oh my gosh, I'm screwing up like crazy. So, as I was saying, I would highly recommend learning this. Some interview questions have a lot of this, and you'll really be more of a rock star. It'll show a lot more experience and knowledge if you understand this basic stuff. It comes up a lot in more advanced topics. Anyway, so here's your hexadecimal values. And so how does this map to characters, right? So let's talk about that, right? So let's take what we knew back in the Boolean demo, and we said, not Boolean, sorry, the character arithmetic demo, and we knew that we set my char equal to 90, and we got z. So here's where I want to break that down for you, right? So, okay, so 90. So my char equals 90. So that's the decimal value, right? So let's figure that out real quick. Let's go over here. Decimal value is right here, 90. Looks like the hex value is 5a, right? So okay, so what that means is that it's actually your hex value, or sorry, 0x5a, or that's 5, right? And then a, this value. There's your 8-bit hex, or sorry, binary representation of your character. There is your 8-bit hexadecimal representation of your character, and there is your 8-bit decimal value of your character. Cool? All right. Now let's talk about Octal. Not used very often, I will say. So Octal has a value of 0 to 7. Okay? So 0, 0, 0, because Octal would be 3 digits only. 0 through 7. 0, 0, 0 is 0. 0, 0, 1 is 1. 0, 1, 0 is 2. 0, 1, 1 is 3. 1, 0, 0, 4. 1, 0, 1 is 5. 1, 1, 0 is 6. And all 3 as 1 is 7. There you go. So that's Octal. I honestly don't see it very often in any of my work. So just be aware of its existence kind of deal. Cool. So binary. Once again, you already know this. So it's the values of 0 to 1, right? So it's probably pretty dumb to even do this, but 0 equals 0. And 1 equals 1. Ta-da. Pretty complicated, huh? So essentially what you've got here is different ways of representing different formats of integer values that all relate to the same system. So your base is going to be decimal because that's what we use as humans. But being able to translate to hexadecimal, super useful for, dealing with memory allocation, which is where you, let's say you've created a bunch of objects or code that creates objects, and those things have to be stored somewhere, right? And they get stored in your RAM. That's why you get RAM for your computer, because you got to store things in memory. And when you do that, those are stored at a memory address, which is a string of hexadecimal digits. And when you know where the memory is, you can start to poke around manually in that memory, and you can say, get me the data that's at the memory at this location, and you can actually read computer memory manually. A lot of cool things you can do. All right. Let's see, where are we now? All right. Let's see. Okay, character escape sequences. Cool. First one, well, actually, I'm just going to kind of write these out and make another table. So I'm going to list all of them, and we're going to test a few of them, and so you can kind of see how they all work. So these are going to go inside single quote, so we can kind of show you. Well, not here, but I'll show you them in that way later. So we can do a backslash single tick. Now, back when I showed you the character arithmetic, we defined this character of value x, and it had a single quote. That kind of put the character between single quotes. But if you had a string and you wanted a single quote to be part of that string, if you put a single quote, it would kind of say, hey, I'm about to start the beginning of a character or a string, and it's like, that's not what I mean, right? Like, I want to actually show a tick mark, and that's how you do this, right? You have to escape it so it knows that you're being literal about that, right? So this is going to be a single quote, right? And so you're also going to want to, you can also do the same with a double quote, and that's a double quote. So that's a literal, right? If you want a backslash, you do the same thing, right? Next slash. Cool. So /r is a hidden literal, which is actually a carriage return, right? So it adds a carriage return in the string. And then /n is going to be a new line. This is a new one to me. A form feed. I've never used that one. /t is a horizontal tab, right? Let's see what else we got. /b is a backspace. That could be interesting. Oh, this is weird. So slash DDD. So this is actually an octal constant where DDD is an octal constant. So I would assume you could like put an octal value, right? And it would, I guess it would just do its thing. Interesting. This is another one. I think I have used this one before, not very frequently. But this is slash UXXXX, and this is a hexadecimal constant where quad x is a hexadecimal constant. Let's fix that up. Cool. So let's try a couple of these, right? So do system out, print line. Let's see. This is a single quote, and then we're gonna do slash single quote, and notice how it changes to orange, right? So let's come over here. Let's clear the screen. Java C Blackboard. Huh. That's funny. It's trying to read my command here. Let's see if I add a space there. Oof. Why does it think that's code? That should not be a thing. Let's try faking it out here. Let's see if we can make it. Huh. That's funny. If I do that. Is there anything I can do to make that work? That'll work. Okay. We'll just put that. Remember, there's no space there. Apparently you can't do that in a comment. That's real weird. Okay, so let's run that. Cool. So this is a single quote. All right, so let's just kind of copy this and let's start doing this for everything else. So this is a double quote, so we're gonna change that to a double quote. Let's say this is a backslash, right? What's the next one? A carriage return. This is a, and then we're gonna do a slash R, right? Carriage return. Okay, so that'll give us a carriage return. And this is a new line. Okay. What is a form feed? What is that? Okay, let's compile that. I'm curious in these that we have so far. Okay. I compiled that, clear the screen, I'm running it. Cool. So this is a single quote, check. This is double quote, check. This is a backslash, check. That's interesting. Where's the rest of my string here? Huh. Yeah, it looks like it truncates this. So if you want both lines of text, you have to use a slash n. This is a new line. Form feed, not sure. That's, might want to do some research on that one. I might do that myself. Let's do a horizontal tab, because that's important. So we'll do a slash t, tab is done. So you can kind of see the difference between those two. Let's do a, this is a backspace, and let's do slash b. I wonder what that's going to do. Let's compile that. Let's clear the screen. Okay. Yep. So the horizontal tab added this, right? And the backspace, not sure. Might want to research this. So once again, Sometimes you're going to find things you've never used and that you don't know what they do, even though they come from the foundations. It's good to kind of look those up. Sometimes you can just look them up when you need them. It's good to be aware that these exist, though. Let's see if we can do the hexadecimal one here. So this is a hex value, and we're gonna say /u 0x5a. Is that how that works? Let's figure that out. Let's go to Google. Java hexadecimal escape sequence. Ah, it's just 0, 0. So there's no X. It's like that. Okay. So let's compile it. Let's run it. Oh yeah, look at that. Remember how we said 5a was Z? So if we go over to Google again and we go to our ASCII table, which is our first one here, and we said, what was it? 5a? is right here. Z. So we've just kind of proven that. It's pretty cool, huh? And then, you know, you can do the same thing with Octal. So you could say, well, I want the value for, let's say, an Octal constant. How did they do that over here? Right? So looks like they did it in binary. So we said our Octal value for 101 was 5. So let's try 101. So we do 101. That should print 5, right? Let's try that. Clear the screen. Hey. Well, that's interesting. Why did that happen? Zero. Sure doesn't make a whole lot of sense to me. 101, what would that be? That's 5. Oh, 101. There it is. Yep, the oct value of ASCII. Okay. Yep. So the binary representation that we put in, that's not binary, that's the octal value. So let's just say we wanted to put in something like 165, right? So let's say we want the octal value, character value for 165. And so 165 should get us u, lowercase u. And there it is. Okay, that makes more sense. It's not binary, it's the octal value. Okay, cool. All right, so those are essentially escape sequences. Awesome. All right, so let's talk a little briefly on string literals, which we already kind of did. We said string literals, if you look up here in the notes, this is a string literal, right? It's either a character or a string. So we're going to do a string, where's my string demo? I don't have that. I'm going to make that now. Come on. Cool. Let's copy this. Copy this. Let's get rid of this. Cool. All right. Oh, you know what? No, I don't need to do this. I'm sorry. Basically, I did this in the Blackboard. Yeah, everything I was about to just go through is stuff we've done down here. So these are string literals. When we print this is a string literal, and we're using these escape literals within those strings. But essentially, just remember that this is a string literal. You can escape things within the strings using these escape sequences. You can also so you can say I have a tab delimiter, and it's equal to that, right? Well, and you could do something like this. So let's get our we're gonna copy this one, and we're gonna say new tab is done. So what we're gonna do, right, is we're going to, I know this is inefficient, I said don't do this, but I'm not gonna worry about it for now. So we're gonna go ahead and say, right, so we're basically concatenating or adding these strings together. So we're adding this string or this character in between those. And what do you think that's going to do? Because I think what it's going to do is it's going to do the exact same thing that it did up here. It's going to insert a tab, because a variable can contain the value of a tab. So let's find out whether I'm right. Okay, let's clear the screen. And there it is. Same thing. Right? Cool. So remember, all these can be stored in variables as well. All right. Now, where are we at now? Cool. Okay. So, initializing variables. All right. So, generally speaking, you can only initialize a variable with something that is equal to its type. There are a few exceptions. The first that comes to mind is the one we've already gone over, which is a character can also be given the value of an integer. But basically, all of these instances of initializing variables, like initializing my char, initializing my Boolean, these are all variable initializations, even this tab delimiter. And that assigns a value to that variable, and that variable is basically a chunk of memory in usually a RAM, right? So there's a chunk of RAM that your computer says, okay, this program says I want 8 bits worth of memory, and I need it to store this type of data, right? So it essentially allocates or sets aside this section of RAM for your data to exist in. And so somewhere it's like a mailbox that gets created, right? So imagine that you go to the post office and say, I want a post office box. And they're like, okay, cool. Generally, you're going to do that. You're going to open the post office box. You're going to have it open for what? Like a long period of time, right? Like a year, 2 years, 3 years. This is something that you may have open for like a millisecond, right? You have it like a very short amount of time. So your program is constantly like subscribing for post office boxes, right, to store stuff. And then once it's done with it, it's like, oh, I don't need this anymore. It chucks it, right? Gives it back to the system. And that's essentially what a variable is. You're basically saying, I need this, and I need to store this data. And so the variable is actually linked directly to the memory address in RAM. So it knows the actual address of the post office box of where to get what it's looking for. So that's where hexadecimal comes into play, because that memory address is represented in hexadecimal. Okay, so that's initializing a variable, right? Now, I'm gonna show you. So we can have, like, let's just say we have int a, right? And then we say I'm gonna have another int, but I don't have to explicitly say int b, because it's comma delimited. It's going to assume that b is also an int, right? And I can actually initialize it, right? I can say c equals 19, and then I can declare d. Now, this is important because b and c have initializations. A and D do not. Okay? And one thing I will say, always initialize your variables. Don't ever not do that. You always want to initialize your variables. Because I do believe in Java, it's smart enough to give it a default value like 0 or null or something like that. But it's just bad form. It's just bad form. And you'll eventually get called out on it. So don't do that. When you have an explicit default value, the developer that is looking into why your code failed can go look at it, at that code later, and say, oh, okay, this is what the default value is supposed to be. So what I'm seeing is correct in the failure. That's not the issue, right? But if they're seeing something that makes no sense, they're going to say, oh, that guy never gave it a default value. This is now becoming a pain in my butt, right? So don't be that guy. All right, so let's see. I think it's this one, dynamic init. Okay, so we're going to demonstrate dynamic initialization. Okay, so I'm going to run through this program and I'm going to describe it as I go. Right. So dynamic initialization is when something is calculated during a program running. It's not something that's in code. So for instance, this here is, it's not dynamic. I don't know if it's called static, but basically these are declared at compile time. So automatically compile time, your program will know what the value of radius and height is. You'd never write code like this probably. Maybe, but generally this kind of stuff like radius and height is going to be dynamic. But for the purposes of the demonstration, we've created these compile time values, right? Compile time initialization. So then we can dynamically initialize the volume. Right, so let's go ahead and declare a variable called volume, and we're going to say that it's equal to 3.1416 multiplied by radius. So it's basically pi r squared height, right? I think that's a cylinder, if I remember correctly. So that is dynamic initialization of volume, and then we can print that out, right? Cool. And so at compile time, the radius and height will already be known, right? But the dynamic value of volume wouldn't be. It's not until we run the program that this value will be calculated, as it is shown here. Okay, so that's important, right? Not too important, but still important to know, right? Because your programs generally need to be dynamic. They need to operate based off of incoming data, not based off of some hard-coded value. These are called magic numbers. And pi is okay to be a magic number because it doesn't change. It's always the same. But, you know, generally you want to write a program where the radius can be fed into your program or something, right? Like you wouldn't want that to be hard-coded, and that's a magic number. So try not to do that unless you know it's a value that's never going to change. Okay. All right. Now we're going to talk about scoping. All right. Okay. So I'm going to read some theory off of this thing over here. And I'm going to explain it as I go. So basically, Java allows variables to be declared within any block. And a block is something like this, or something like this right here. So anywhere in those curly braces, right? And so it starts with the opening curly brace and it closes with the closing curly brace. Imagine that. So every time you create a new block like this, you're creating a new scope. So essentially, this here this radius and height only exist within these curly braces, right? So you can't access it outside of it, right? So we're gonna kind of go through a little bit of like examples to kind of show how that works. So first I'm gonna do this example over here called the scope demo, right? This just gonna demonstrate some block scope, okay? All right. This is also really important because, you know, as a developer, sometimes you don't want your values to be available to other developers, or sometimes even to the code that even you yourself are writing. Because you might come back to your code in 3 weeks, and then you might be like, oh, this is something I can use because it's there and it's available. So you access it, you change it, and all of a sudden your program doesn't work anymore because you didn't intend for yourself to use that. So just like writing protective defensive code against other developers is important, it's equally important to write protective defensive code for your future self, because your future self might be completely ignorant to what's going on in 6 months. And that's also why we comment our code and say, don't touch that, don't do that. Don't make this public, don't change this value, don't do this, don't do that. These are all important comments. All right, so we're gonna create a variable called x, right? That's not what I wanted to do. Okay, cool. So as of right now, this is known to all code within main. Everywhere in main can touch this, right? So we're gonna go ahead and we're gonna modify it, right? We're gonna say, okay, if x equals 10, which it does, right? And then we're gonna do curly braces. Now, important. This starts a new scope. Remember, curly braces, right? So then we'll create another integer called, let's get some space here so you kind of see what's going on. So we're going to say another integer, right? And this one's called, assigned to 20. And we're going to say known only to this block, okay? So as of right now, x and y are both known here, okay? So we can say x equals y times 2, and that's perfectly valid, right? So we're going to go ahead and let's see. We know that x is known to all code within these two curly braces, so x is still known here. Whoop, lost everything. Okay, so x is still known here. So we should be able to say, because we updated x here with y times 2, we're going to say system.out print line, right? And we're going to say x is, jeez, what's going on here? Okay, so we're going to file that. Now we're going to run it. Okay, cool. So x is 40. So let's run through that. If x equals 10, which it does, so y equals 20. So 20 times 2 is 40. X equals 40. Okay, checks out, right? So now we're going to try something else, right? I'm going to say y equals 100. Okay? Because I declared y in this block, right? And I'm telling you that it should only be known to this block. So you should be confident to tell me, if you trust me, that this is not going to work. So let's find out what that does. We're going to compile it. And womp womp, cannot find symbol. Right? Y equals 100. It says doesn't know what y is. Oops. And the reason for that, because it's not in scope. Not in those curly braces. This is important, and it applies to every scope of curly braces anywhere. You can actually do some crazy things like this. You can say, I'm going to say I'll make my int z equals 10. And you might be like, well, that seems kind of dumb. Like, why would I ever want to do that? But there's actually, I think there's a trick you can do. And I have to look this up. But I want to say that you can actually create a static final int my int or something, and you can set it equal to z. And I think that you can print that out. Watch me look like a fool. If this doesn't work, I'm going to abort mission and come back to it later. This is way too advanced. Let me finish my comment here. So error y not known here, right? Okay. So we know that this didn't work. I commented it out, so the error goes away. But now I'm adding this block, and I want to see if this actually works. All kinds of crazy stuff's going on here. Yeah, that's not gonna work. We're gonna abort that. There's a way to do that. So we're gonna come back to this later, okay? Cool. All right. So ignore that mess up there that I just kind of tried to go down a rabbit hole with. All right. So what are we doing now? Okay, cool. Now we're going to show you the lifetime of a variable, and we're going to use a for loop to kind of demonstrate that, all right? So let's create an integer x, and let's actually do the right thing and put it on its own line. Let's create a for loop, all right? Let's start at x equals 0. Let's say x is less than 3. And then plus plus, is it? Yeah, plus plus x. All right, cool. So x is available anywhere within these curly braces, right? And it's also available in any further down that chain of curly braces. So in closing curly braces. So we've just, this is nested closing or curly braces. This is nested scope within this scope here. So this outer scope. So this is called nested scope. Okay. Gonna create another y, right? We'll set it equal to -1, right? And put a comment here that y. So y is initialized each time the block is entered. Okay. All right. So what I want to do here is print out y is y. So that's just going to print y to the screen, right? So this is always, this always prints -1. Cool. All right. I hope you enjoyed that mix by Mazisis. We'll have someone else on Thursday. So be ready. In the meantime, I'm going to put something else on. We've got probably about 15 minutes left or so. So let me just put this on.
Andy,
and yay, SoundCloud decided it's going to go ahead and plug something. So we're going to turn that volume off the next 30 seconds. All right. So say y is y. So we're going to print out the value of y, right? And then I also I want to say, okay, we're going to update y to 100, okay? And then we're going to do, and let's do this. So y is now, okay. Now, all right. Now this is going to loop 3 times. 0, 1, and 2 for x, okay? So that's taken care of. It's going to do this 3 times, right? Each time this enters, X is going to update, which means X is valid scope because it's here, and it's going to update here, and it's going to run this code 3 times. Every time this opens, it's going to initialize a new value of Y. So it's going to say, the first time this runs, going to be, hey, Mr. Postman, give me a mailbox for Y. Okay, sweet deal. Here's Y. Here, let me put -1 in it. Awesome. Let me print that. So it prints -1. This could be like, now put 100 in it. Cool, print 100. Comes back. Now, after it gets to this curly brace, it goes, cool, my for loop's over. Here's your mailbox back. And then it immediately says, hey, I need that mailbox again. Let me put -1 in it. Let me put 100 in it. Oh, let me give it back. Just kidding. Let me get it again. And it's going to keep doing that loop of insanity. So this is okay. Sometimes you want to have a local scoped variable like this. Okay. Sometimes you don't. Sometimes you want the variable to persist across multiple iterations. That's why you declare them outside. Right? So even if you declared the int here, right, and put it here, that's still outside this scope. Right? So for the purposes of this argument, I'm just going to leave it like that. So let's compile that. Java C nest. Is it nest var? No, variable int. Yeah. Cool. Let's compile that. And ta-da. Same thing 3 times. Completely pointless. So that's nested scope, right? So we have a not nested scope. Sorry. We have an integer within the scope that gets reinitialized every single time. So it just kind of shows you that this is going to be used throughout this scope, but this does not get used outside of this scope. So every time the for loop runs, this gets created anew, right? So if you're doing things across thousands of records, any variables you declare in that process at the beginning of it are completely created again from scratch. All right. Let's see. The next one I wanted to go over was nested variables. So the intention of this program is not to compile. So what we're going to attempt to do is declare a variable in an inner scope with the same name as one defined in an outer scope. And I'm going to explain to you what that means, what to look out for, and why it doesn't work. Okay? Cool. All right, so after this, we've got one more. Yep, we've got this and another one, and then we're done. So we should go about 10 minutes left. All right, cool. All right, so we're going to declare an integer called count. All right, and we're going to start our for loop. So count equals 0. Count is less than 10, so we're going to loop 10 times. We're going to say count equals count plus 1, and I'm doing that to just show you that you can do that increment multiple ways. Right? So the first thing we want to do is we're going to print that out. So there's the value of count. Okay, awesome. Now we're going to attempt to create a new value called count, and I'm going to show you that this is illegal. Right? Because let's assume, oh, come on, let's do that. I want to do this again. I want to do, okay, cool. Count is equal to 0 again. Count is less than 2. You know, count plus plus, right? And system out, print line, this program is in error. And I don't think we should ever see this because this should never even compile. But let's find out what happens. That is nest var. Oh, I have an error. Cannot do that. Wrong. Let's do that again. Aha! Variable count is already defined in method main. So let's go ahead and grab this. Let's add our block, and let's just show that in there so you can see what that error was. Okay? So you can't do that. So if you try to redeclare a variable of the same name in a lower scope down from the scope you're currently in, won't run, won't compile. So we've created count here in this scope, but because this scope is inside this scope, and it is also trying to use the variable name count, it's going to blow up in your face. And that's not fun. So don't do that. Cool? All right. Last one. All right. Which one was this? 1 second. I know we already did this. This was part of the blackboard, so actually we are done now. We're gonna delete this. Whoop. All right. So the string literals was basically this. This was all your string literal stuff. Okay, awesome. That wasn't too bad. That was about a little over an hour. Trying to keep these a little bit more bite-sized. It might seem a little fast. A lot of this is kind of dry too. Good deal. So I hope that was useful to you and that you learned something good out of that. I'm gonna jump over to the Zoom and then we can hang out over there if you got any questions. All right. See you later.